Hey, welcome back, everybody. So, in the second part of the lecture on the law of cosines, we're going to see a couple applications of this. So, just remind you, this is what the law of cosines is. Again, it's really, even though you see three formulas here, it's really one main principle, right? That says that we have one side, the square of one side is equal to the sum of the squares of the other two sides minus 2 times whatever the lengths of the other two sides are times the cosine of the angle that's opposite that side. Okay. So first one, unfortunately, has to do with baseball. I don't know if you guys like baseball or not. I used to like it. Now I absolutely hate it. I think it's a dumb sport, and I think where two millionaires play catch, and sometimes, occasionally, like 2% of the time, maybe something interesting happens. But I'm sorry, I'm from Cleveland. I'm a little bitter with my team. Things seem to be always rigged against my team, the Indians. Okay. Anyway, but a baseball diamond does look at. They're all made the same. They have it's really a square, and each side is 90 feet. And then we have within the pitcher's mound, there's something called a pitcher's bar, I guess, which is supposed to be exactly 60.5 feet from home plate, where home plate's right here. First base is here, second base is here, and third base is here. Now, in the first question they ask is, how far is it from the pitcher's bar to first base? Okay, so that is, you want to find this distance, okay? Well, how do we do that using the law of sines? We know the length of this side, we know the length of this side, and what's this angle? Well, since this is a square, the angle from here to here is 90 degrees, so this is half of it. This is 45 degrees, right? So therefore, if we're trying to find this distance, if we call this x, then x squared will be equal to 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times the cosine of 45 degrees. Okay, and this turns out to be 4,059.857, and then we take the square root of both sides, and we get x is 63.7 feet. Okay. Okay, we'll put the units on here because this is a word problem. All right, so that is that's that distance. Okay, what's the next question? How far is it from the pitcher's bar from to second base? Well, that is this distance right here. Okay, and if we call this distance y, well, the way we can see that is that we have a right triangle here. You know, where at a third base here we have a right angle, and so what we have is this situation. Here's 90, and here's y plus 60.5, whatever that is, and we know that this from here to here is 45 degrees, so from here to here is also 45 degrees. Okay, so we can either use the cosine or the sine because both these are equal, so the cosine of 45 degrees, that is going to be the adjacent divided by the hypotenuse. Okay, and so we can do a little algebra. We can cross multiply and divide, and we'll get y plus 60.5 is equal to 90 divided by a cosine of 45. All right, and so then 60 plus, or y plus 60.5. Well, actually, we can just subtract now, so y is going to be 90 over the cosine of 45 degrees minus 60.5. And I guess this is 66.8 feet. 66.8 feet. Okay, and then finally we want to find if the pitcher is facing home plate, by what angle must he turn to face first base? Well, that's this angle right here. That's what we're trying to find. That angle the pitcher would have to turn. So I don't know what you want to call this. I guess we'll call this alpha. We can use whatever Greek letter we want. But now we have this situation where we have 90 is the side opposite, so we have 90 squared is equal to 60.5 squared plus x squared minus 2 times x times 60.5 times the cosine of this angle. So, yeah. Okay, but we know what x is, so we'll just replace it with 63.7. And then do what we did before. So the cosine of alpha will be 90 squared minus 60.5 squared minus 63.7 squared over negative 2 times 60.5 times 63.7, and this turns out to be negative 0.0495. And then if you take the inverse cosine of both sides out, it turns out to be 92.8 degrees. So almost 93 degrees. All right. So I'm sure glad we know that now. Next time we go to a ballpark, right? All right. Let's look at the next example, which doesn't have to do with has nothing to do with baseball or sports. It's something I like doing a lot better than baseball, and it's boating. And in this case, we're boating from one island to another. They're 100 miles apart. And a boat leaves island A, heading 25 miles per hour. After 2 hours, the crew realizes they are 25 degrees off course, maybe because of wind or something. How far is the boat from island B, and what angle must the boat turn to get back on course, and how long will it take to reach island B if they are going at the same speed of 25 miles per hour? So it's constant speed. And this is the picture to like straighten things out, see what's going on. So this is the original plan of the boat, but we were off course by about 25 degrees. And so they're here after 2 hours. Now, after 2 hours, of course, they were going at 20 miles per hour. Okay, and then, so after 2 hours, of course, that's 40 miles. So this distance is 40. Okay. And the first question they ask is, how far is the boat from island B? So we want to find out what this distance is. Okay, well that's not too bad now, right? Because we know this side, and we know the angle between them. So if we call this, should we call this x again? Sure. So x squared is going to be 100 squared plus 40 squared minus 2 times 100 times 40 times the cosine of 25 degrees. Okay? And this is approximately 4,349.53. So taking the square root of both sides, we get x is 65.9 miles, I guess. All right, and now, so that's this distance. Now, whether they ask, what else are they asking? How long will it take them to, what angle must the boat turn to get back on course? Well, I think obviously what we want to do is find this angle and then see what that means for our boaters, okay? So we can find what this angle is if we call this, let's call this beta. Okay. So now we can use the law of cosines again. So we get that, in this case 100 is the side opposite beta. So we get 100 squared is equal to 40 squared plus x squared, and x we know it now is 65.9, okay, minus 2 times 40 times 65.9, okay, times the cosine of beta. And so the cosine of beta, this which is approximately negative 0.76957. Okay, so alpha, so beta in this case is the inverse cosine of that, and that's 140.3 degrees. Okay, so what does that mean for our boaters? They have to turn in this direction, right? So if they are, I guess if this we are boaters, so this was our path of 40 degrees. Okay, if we're going in this direction, if this is straight for our boat, the angle that we're really interested in is this angle, right? So we actually have to go this angle, and then this angle would be well, this angle and this angle have to be 180 degrees, so this would be 180 degrees minus 140.3 degrees, which I think is 39.7 degrees. Okay, technically I guess it would be 39.7 degrees northwest of north. I guess. Okay. All right, so that's what we would want the boat to turn, and then the last part, that might be the easiest part. We have to go this distance, and we're going. How long will it take to get there? Well, this is the distance. The constant rate is 20, so we we take this distance divided by, well, distance equals rate times time, so the time is going to be this distance divided by the rate, so the time is going to be the distance divided by the rate, which is 60.5 miles divided by 20 miles per hour, and this turns out to be 3.295 hours. Okay. All right. So, basically it's going to take, because of this little detour, it's going to take them about an extra 18 minutes to get home, to get back to the island. All right, get from A to B, and that's not too bad. So, look at these examples, study them, then get a lot of practice in with your homework, and I'll see you next time.